Besides the layers of a wall, we might also need to add some constructability detail to our model, such as perforations or gaps. We can imagine how that could also affect our materials, depending on whether we count wall materials net of holes or not, but it's certainly nice to have the flexibility. So here we're going to use our divide parts capability. Let's take a look at dividing this wall to account for two construction considerations: installation sequences and possible penetrations through the wall. I could set a reference plane in which to draw, but I will just let Revit automatically sense that I'm drawing on the face of the wall. Accuracy isn't important for the demonstration purposes, but keep in mind that we could use some reference dimensions to get these lines exactly in the right place. I'm going to go ahead and place these vertical lines more or less here to account for how these wall segments will be installed. And besides the installation sequences, let's think about the penetrations. We can go ahead and draw shapes for anything that we might have going through this wall. It could be a conduit chase, or where we have a large MEP system coming through. Maybe we've got a group of pipes or a large pipe coming through. So I'll go ahead and add 2 perforations for situations like this. And now, when we hit the green check mark, we get to see a preview of how it's going to be cut up, and then we go ahead and accept the edits. Then we'll take those whole shapes and use the exclude functionality. Let's go ahead and select those and choose exclude, so they go away. And now we have the spaces and penetrations in our wall that we need. Just to show that we can, I'm going to go ahead and change this top right part, just the interior face of the wall part, to a different material. First, I'll need to uncheck Material by Original, then I can enter the material properties to select aluminum. Now, returning to the 3D view, let's make one more split to our model in order to reflect a level of detail about material that we cannot see now, this time for the foundation. First, I'll need to quickly model a foundation covering the entire footprint of the building. Because I know that I will have a basement below one part of the model, I know that I'm going to need lightweight concrete in that area. From a level 1 view, I will sketch that slab using pick walls and trimming. I'm going to adjust the level so that it appears just below the floor, and I'll accept that. In this special view, where I've isolated the foundation, I'm going to sketch the parts division, which will allow the material division. I'll leverage my grid lines since they match my basement division program. We'll choose both grids since they will be needed for the concrete pour sequences anyway. I'm going to select all in order to be able to turn off the Material by Original checkbox, thus allowing me to change the material of any of them. And for this first leftmost piece, I'm going to define a new material property. It's going to be lightweight cast-in-place concrete. And then, opening my 3D view, I will verify that that change occurred. Now with those material property definitions for parts being made, let's see the impact they had on the material schedules. At an original wall level, the materials report without the parts detail, showing a total volume of 1143. But in the part schedule, we are capturing the material changes and punch-through omissions, showing a reduced volume of 1132 cubic feet. And of course, capturing the aluminum segment. Now what remains is to make a similar part schedule for the foundation. I'll duplicate this wall part schedule, rename it, then go into the filters to find the foundations. And here we can see that the cast-in-place for the lightweight concrete was separated out.